Can you see my screen now? Okay, very good morning. My name is Alex. I'm from Electronics. Today is a very honor to have this session together with SHRDC. I'm going to share about the role of MES in manufacturing industry today. Before I start, let me do a very quick introduction about us. Okay, Electronics, we have office in Johor Bahru and also in Cyberjaya. So our company, we have actually a team with more than 18 years experience in MES implementation. The industry we have implemented including semiconductor, EMS in PCBA box build, automotive, metal precision, and also wire manufacturing. We work very closely with MPC. We are also MPC certified consultant under MES 4.0. So we have also implemented a few quite numbers of companies. So you can see from the list here, we have done for Panasonic, SKP, Daikin, EDMI, Bionic, Sumitomo, and etc. Okay, before I start introducing MES, I think very important is the challenge of the manufacturing industry today. So in today's markets, I always, when I meet my customer, I always give them a very high respect, okay, for factory. So in factory, I think it's really not easy because customer demand is getting higher and higher. And I'm sure if you're in manufacturing, your customer will come back to you every year, ask you for the cost down, okay? But their requirements is getting higher and higher. I have customer, they say, you know, their customer last time, every product they produce, they need to submit 3 measurements of their products. So they have to spend 3 people producing the report for them every month. But now they have to submit 7 measurements. Okay, so customer requirement is getting higher and higher. Cost is getting higher and higher. You have labor shortages issue. Minimum wages is keep increasing. Okay, and you have to compete with so many other countries. Okay, those are external forces. Okay, and here we haven't really included, you know, the challenge from COVID-19. I think this is also one is really unprecedented in the history. You know, we have to experience, you know, 3 months, you know, the operation is being interrupted. Okay, but those are the external forces. But internally, as a SME, as a manufacturer, we got to ask ourselves: are we good enough? Do we have a very good system and to manage our company, our factories? Okay, oftenly, you know, when we go into factory, we always, you know, hear the problem that, you know, they are not getting the accurate production data. You know, they don't know really what happened in the shop floor. Okay, what is the reject rate? You know, what is their real-time outputs? Okay, what is the reject? You know, what caused the reject? The process, you know, is not transparent, and also the maintenance as well. So to compete with, I think, global markets, okay, those, I mean, the cost and also market competition is something that is in the market that is beyond our control. But we can ask ourselves a question is, are we competent enough to compete with the global markets? So I think internally, we have to make ourselves more competitive. I mean, we got to have, you know, a very efficient system to increase our productivities. Okay, so this is a very conventional shop floor management issue. I've been to so many factories, we study their system. Okay, some of them, they have accounting system, some of them, they have ERP system, okay, to handle their raw material, customer orders, planning system. But a lot of time when we talk about the production, the shop floor management, I mean, they depends a lot of paperwork. They have manual production orders. They record the production downtime manually. into these documents. And then the production output, they have job traveler, they write up manually. So end of the day, then they have this data entry clerk to key in all these things into the Excel. Then from there, by the time they compile the report, the management get the data is only tomorrow or 2 days later. So despite like all the manual work they have to do, right? But the decision, come into the shop floor is always too late. For example, okay, you have the downtime, happen today, but you can only, know, management only can know the next day. So the decision is actually is too late already. And furthermore, all the data being collected manually is written down by the operators or by the line leaders, but the data integrity is oftenly a question mark. Okay, so this is the so many years experience that after we speak to so many manufacturer in Malaysia, especially SME. I mean, in the shop floor, really they don't have a system. Okay, so what is the MES? MES is basically it's a shop floor system. Okay, it's a computerized system used in manufacturing to track and document the transformation of raw material to finished good. Okay, so give the management information, how you can actually know the current condition of your shop floor, and also from the information that you collected, right? So you know how you can optimize to improve your production output, and also control the multiple elements of the production process. In short, I think in the manufacturing world, right, we talk about 4M. Okay, materials, manpowers, machines, method. Method is basically the production process. So the 4M, some company, they say, oh, I implement 5Ms, I implement 8Ms. So, but basically you can't run away with this 4M. So what material you use to produce your products, who is the person that doing the job, which machine that you are using, okay, and then what are the production process it went through. So this is what the answer MES system can provide to you. So in other definition by MESA, right, or MES also defined as a dynamic information system that drive an effective execution of the manufacturing operations. So MES is purely designed for the shop floor. It covers, every facets in your shop floor, and it also do the track and trace of the WIP, okay, to give you the full product genealogy. So product genealogy here means that, so when you have a finished good, okay, so being produced, MES can tell you which lot of the material you're using, which tool you're using, which operator doing this job, what are the quality data, okay, which machine that you use to do this. Okay, so basically it gives you a full product genealogy of the product that you produce. And also it helps you to collect critical manufacturing information like the yield, your defects, your downtime, the cycle time. All this data is very, very useful nowadays. Okay, because I think the manufacturing have changed a lot. Okay, the speed of the model change, the product life cycle, last time we talked about 18 months. Now, I think you don't have the kind of luxury. Okay, so, and then a lot of data that customer want you to provide to them, including like, when I produce this part, right, uh, which machine you are using, which mold you are using, what are the mold number, all these things, right? So all this data that, you need to provide for customer. Okay, when you have all this information, right, it is very useful when you actually deep dive to this information, right? It can use for your process improvement. Okay, so if let's say you don't have those data, right, definitely you don't know what's the problem that happened in your shop floor. Okay, I think this is a very important topologies. I think I hope to share with everyone here in a manufacturing topologies. Okay, so there are actually 4 layers. There are 4 layers in today's manufacturing topologies. Okay, the first layer is machine control. This talk about the sensors that you have in the machines, or you have tester, you have measurements tools, equipments. Those are the tools that actually you use to involve in your process of the manufacturing of your products. Okay, so there is a gap in between ERP and machine control, because a lot of time ERP, they do not link to machines. Okay, so you need another layer of the system we call MES to gel these two together. Okay, and then of course after ERP you have a business intelligence for you to do a lot of reports, dashboard. Okay, all these business analytics tools. Okay, so from machine level to ERP, we talk about is a real-time manufacturing, meaning that we talk about second, we talk about minutes. Those information has to fall to MES. Okay, so but if you talk about ERP, usually it's a delay management. Why I say delay management? Because ERP doesn't really, like for example, after you finish the production of one unit, okay, ERP, you don't really do a job receipt. Okay, you will do it either by shift or end of the day, then you do a work order receipt. So that is actually a delay management. But in MES, every unit that we produce, we will record the output. We will minus off the material that you use to produce. So your real-time output, also the WIP, the stock levels in your shop floor. So information is from the bottoms up, okay, and then the decision is from the top to bottom. Okay, on the machine level, oftenly I think now we call it operation technology. We call it OT levels. So this is actually we talk about sensors. We talk about machine. Okay, so and then you do machine data acquisition. And there are some company they even have SCADA system, right? They can do a real-time monitoring, control also. Like for example, when you have SCADA, right, you can control the machine or the sensor give you, for example, the temperatures. If temperatures, exceeding the limit, oh, you will stop the machine. Those are on the OT level, or it give you alarms. Oh, this thing already over the limit. Okay, so it gives you a real-time alarm. Okay, so what about MES? MES actually, it takes case, it communicate from the OT to the ERP. So ERP taking care of your accounting, your supply chain, your MRP, your production order plannings, and some is even up to the schedulings. Okay, so they will based on whatever the customer order that you have, and based on whatever stock you have, they will do an MRP calculation. They will suggest to you what to produce. Okay, what material to buy. So, and then when you go to the detail, right, the manufacturing order will be, we will actually integrate with ERP for the manufacturing orders. Then for the manufacturing orders, the detail, the nitty-gritties, you talk about the IPQA, which operator to produce, to perform the task, right? Whether this operator is qualified to do the job. All these things is under MES. Okay, and MES also taking charge of the material usage, lot control. Okay, for example, if you have, process 1, 2, 3, so process A using component A. So after, process A completed, I will based on the BOM, I will actually deduct the usage. Then I will know what is the balance stock that I have in my shop floor. And OEE, we talk about how we link to machines to give you the availability, the machine downtime, and also the reject, all this information. I believe later on, Dr. Chua will cover more on this. Okay, data collection, I think this is important. Okay, a lot of the engineering data is being acquired from the machine, and the information is actually staying at the machine. Okay, usually you can view those data via the HMI of the machine, but how we can actually collect all this data to use it for analyze the performance, or even doing some predictive maintenance, for example, the temperatures. Okay, so you can actually have the profile, you can set the hour limit, under limits. Okay, then before this happen, like reject, right, or even the machine going to break down side, then they will give you the alerts. And also SPC, and a lot of our customer, they do online SPC. Okay, we don't really, some of customer last time, what they do is they'll collect the data, they record into Excel, they key into Excel to plot the chart. But if let's say when you have MES system, right, you can do an online SPC. And also WIP tracking. So WIP tracking here, we talk about a detailed WIP tracking. Okay, in ERP, right? So usually the tracking is based on work order. But in real manufacturing, right, I think some company, they will issue a bulk work order. But in between, right, they have a lot of small lot. Those lot tracking, right, and then what process completed, reject, whatever, right, is being handled in the MES. Okay, so after the good is being manufactured, okay, and then all this data, then we will fall back to the ERP for the integration. Okay, so I think the last level will be the BI. We talk about dashboard, cloud computing. You can do big data, and importantly, is always when we go to a factory to share with them the MES system, right? We are asked the boss, hey, in today's business, can you using mobile phone to check your current operation status? For example, what is your plan versus your actual? Are you getting the real-time data? What is the machine that currently is breakdowns? So can you acquire all this data via tablet or via your mobile phone? Or you have to call to your office to ask your production managers in order to get this information? So if this is the case, right, I believe it's time for you to look into MES system, because in the ever-changing business now, you really need to have a system to give you a real-time insight of your production situation. So I think this is the manufacturing topology. And next, I would like to also share, I mean, this is another level. It's the same thing. So, but here I want to highlight is the time frame. So just now on the OT level, right? So we talk about the time frame is very short. Okay, usually we talk about second, sub-second, minutes, or even hour. This data is being collected from machine. It's collected from the sensors. Okay, so you need another level in MES, whereby also we collect the data from the level 2. Okay, this information also will be using in the MES. So in MES, we talk about the time frame is second, minutes, hour, or by shift, or by day. So MES, we talk about, we monitor the workflow, the recipe control, okay, maintaining the record, and also optimizing the production process. Level 4 is ERP. So ERP, usually you don't go up to minutes. You don't really do back flushing every minute. You don't really do production output every minute, but usually you do it by day or by shift. Okay, so and then some other report, inventory report, your financial report, you talk about weeks, you talk about months. Okay, you don't really monitor into the so detail. Like for example, I issue 1,000 unit to these production orders. Okay, but I want to know now at any one time what is my leftover unit in the shop floor. In ERP, you cannot know. But if let's say you have MES, okay, MES will, based on the quantity that you have completed in real time, then minus off the component that you use based on the BOM. So from any time you know that what is your real-time WIP in your shop floor. So what other things that MES provides? Okay, a few things that I want to cover in more generous. Okay, first is the product definitions. Okay, product definition basically is all the things that involve to defining how to make a product. Okay, for example, you have certain like production rules. Production rules meanings that Okay, so if let's say I'm using these components, okay, if these components you have a flow life, for example, like you are doing the electronic, okay, you use solder paste. So this solder paste, after you issue to the shop floor, within 24 hours, okay, you have to finish it. If more than 24 hours, okay, this thing cannot be used anymore. Okay, those are the rules that you set in MES. So MES will keep track to make sure that, oh, if let's say expired, oh, your machine cannot run. Bill of material, usually we link with the ERP. So ERP will define the bill of material, and then it will integrate to the MES. But bill of resources, especially the processes, right? Usually MES keep track even more detailed processes. So in MES, we will maintain the we call it a routing, okay, or even the recipe data. Okay, measurement resources including your manpower. Okay, in MES we even maintain to say that okay, your this process only those qualified operators can run. Okay, if let's say this operator try to check in this workstation, okay, and then it's not qualified to run this machine, okay, the system prompt you error. So you also eliminate unqualified person doing for the particular process. Okay, scheduling also because after the work order being released to the MES, then you will need to schedule which production line to run that particular production order. Dispatching of the production orders. Here is if let's say you are doing like metal precision, you are doing some plastic. Okay, your work order is a bulk, but actually when you release, you go by batch. So every batch, then you go through multiple process. So these are the detailed thing that MES will do. So usually MES then after the thing is being dispatched, right? Then you will have a lot of small log, and this log will flow into the WIP. And this is where MES will keep track of this log. What the process it went through, whether it's correct. The process you do process 1, 2, 3. You cannot do process 1, 2, 4. Okay, you got to follow the process set in the MES. If you jump the queue, okay, the system detected, or you're not following the operation design, or system will give you error. In certain cases, okay, we do machine interlocking. So if let's say you jump the process, okay, we will stop the machine because you're not following the design processes that define in the MES. Okay, the execution here is talk about you control the progress, you check on the resources. Okay, so like just like I mentioned, if let's say you are not following the process that design right, and then the system will prompt error. This is very important, especially when you deal with medicals, electronics, something automotive, when it's care about the human life. Your customer will ask you whether you have a system to control whether the operator following the proper sequence or not. How do you ensure that they do not jump? If they say they jump the queue, if let's say they're not following the sequence, the routing, how do you alert the management or the line leader? Okay, so those are the things that is important. If let's say today you are dealing with some medicals or automotive kind of the industry customer. Okay, and collection of the production data, for example, the process data, what process it went through, okay, the equipment status, material log information. Okay, and also MES also give you production performance analysis. Most important, like your plan versus your actual. You want to know from time to time. Any one time I want to know. I plan 1 hour, I got to achieve 500, but in actual fact, what is my achievement? Okay, so and also like OEE, you want to know whether how effective you operate the machine or equipment. So if let's say your OEE level is less than 80, well, then what is the main cost of this lower OEE percentage? And also MES give you the production track and trace. So especially in Johor here, we have a big customer like Dyson's. Okay, so Dyson actually for whatever product they subcon to the main con, right? They want to have track and trace, or even I think nowadays for any like electronic company. Okay, so they really want to know what material that you use to produce the part. If let's say any reject or defects, right, they can very easily trace back to what other lot that is being affected. So this is very important for manufacturers today. If let's say you do some subcon for electronic devices, medicals, automotive, I think this has become one of the norm that the customer requirement to have the traceability. Okay, so and also MES role in Industrial 4. I think I don't want to elaborate furthermore on Industrial 4, but Industrial 4 covers so many things, IT, OT, robots, big data, Internet of Things, smart factory, etc., etc. So there are so many aspects in today's, I think, if let's say you plan to move into Industrial 4, okay, so you talk about AI, you talk about data science, analytics, automated or advanced warehousing, machine learning, robotics. So all these things, there are so many different aspects. But you cannot deny that, I mean, there's those so many things, how you want to gel them together. Really, you need to really have you really need to have a core system that can gel them together. MES actually in Industrial 4 today, right, is actually play as a role of the backbone. Okay, it have to communicate from the ERP. Okay, ERP, after you pass the work orders, okay, to MES. So MES have to cooperate with the robot. Robot will give you some of the operation data, okay, or even engineering data. So after the good is being completed, or then you will send to the SRS, send in the AGV to collect the finished good. So in between, if let's say the goods actually have RFID tag, then you have to link with the RFID reader to tag the things. Or even though you want to do OEE, then you need to have your IoT things to communicate with machines to take the data, or machine learning. Okay, so actually all these things, if you don't have a central system to gel them all together, all of them is actually an island by itself. There isn't any like communication to do communication with all the different aspects. So that's why MES role is getting more important now in Industrial 4 era today. Here I'm going to share a few cases to give you a more in-depth about MES. Okay, so I think the first case that last time in our project experience, right? We have customer, they have a dispenser machine. You can see this is a dispenser machine. So they have a JIT. Okay, last time they do it manually, meaning that worker have to select the controller, what the program that I want to run. Okay, but when it's operated by machine, by human, they tend to have a mistake. So sometimes they use a wrong program, or sometimes they use a wrong JIT. Okay, so that's why the customer contacted us, and then we went in, and then we actually implemented a Poka Yoke. So MES can start with even a very simple system like this. It's like a Poka Yoke. So this Poka Yoke, basically what we do is we have a master for them to key in, I mean, what product should use what program to use what JIT. So, and then we have an IoT gateway. And then what we do is basically the work orders, we come with the barcode. You need to scan the barcode. For the barcode, we know what product they are running. And then we will select, what program to run that. And also, they have to scan the JIT. The JIT comes with a QR code. Okay, we want to do a validation before they start. So if let's say the program correct, the JIT is correct, then only you can start run the machine. If cannot, it's wrong, then it gives you error, you cannot start. Okay, so this is a one simple thing that how you link to the controller and do some validation. And with this, right, then you can eliminate the reject issue. Last time, the WIP, when they select the wrong program, after they realize that, it's wrong, the amount of the glue that they dispense to the finish this WIP, right, is not correct. It causes a lot of defects. And all this is money. Okay, by doing something like Poka Yoke, actually, it saves you a lot of the from the rejects. Okay, the second one is talk about machine data acquisition. This is actually what we do is we're using IoT. IoT gateway. So we link to the machine HMI to take the information such as who is the operators, okay, the machine counters, the output, okay, what order they are running, and all this data, and then we'll transmit wirelessly to this IoT gateway. And then from the IoT gateway, then we have a database to actually do the OEE. Okay, so this customer actually they have a lot of machines in the shop floor. So about 20, 30 of them. Okay, so all this machine right will link to IoT gateway. Okay, via this MES Wi-Fi networks, and it will actually take this data and publish into the Azure. From the Azure, right, then you can do Power BI for your this dashboard. So you can see this is a live dashboard in the shop floor. Okay, the first one, you can monitor your live machine production status by daily. So from here, what machines, okay, running on what products, okay, and then what is their actual output, okay, and then you can also know what are the downtime. What is the downtime? What is the factor for the downtime? And then you also can know, operator management, which operator is running on which machine, which shift. Okay, and then you can see also you have production quantity by machine. Okay, you can monitor real time your plan versus your actual. So by seeing this gives you a eye view of what happened in your shop floor. Oh, so I think with all these IoT technologies, right, then you can have a real-time monitoring of your shop floor information. Okay, this is another case that we do it for EMS. It's electronic manufacturing services. They basically doing a box build services for some MNC company. So this is more sophisticated because you do from the board level, the PCB board level. Every board actually is being marked with the QR code, and then it will go through multiple process. Okay, so the system, the MES system here, we track all the component use, we track all the inspection records, okay, reworks information, what the part you replace until the finished good is produced. Okay, this is a sample. For example, I just give you a brief. Okay, so at first, like a laser mark. So the PCB board will be marked with a QR code. So every board we track because we want to know, okay, this board, when you go to the stream printings, right, what tool they're using. Even before you start, right, when you do the setup, you need to scan, your stencil, you need to scan the material that you use. And then the system will check, oh, this material, is it, being issued to the shop floor more than 24 hours or not? If yes, then you cannot start this machine. Okay. And also, when after stream print, right, it will go to machine inspection. The machine will check the thickness. Okay. If let's say we found out the thickness is too shallow, right, then the machine will give reject. If the thing is already rejected, right, when you go to the next machine, the machine won't process that because before the machine start, they will check with MES whether this board is passed or not. If it's an NG board, they won't process. Okay, so like SMT, we also link to the machine to tag, what the part that you insert to this particular PCBA. Because end of the day, every board, we want to know which lot of the material you use to produce the board. And also for the reflow, we check the temperatures, we check the duration. Because the board, when you go into this reflow, right, the oven, so it cannot more than certain duration. Okay, if let's say more than certain duration before it go to AOI, okay, the system also will prompt AOI, or this board, you have to stop, you cannot run. So all these things, is integrated to the machine. And then all this data, then we will collect, the inspection result. So AOI, we want to know if let's say there's any defect and then what caused the defect. And then if got defect, then you will send to the debug workstation. So then all this data, right, will be compiled in the MES. We do a full product traceability. So for example, like you use your handphone, right? If let's say this handphone got problem, okay. So what the system can do is, we do a backward trace. You scan the serial number of this particular product, then we track back, what are the components, which tester that, perform the job. And then what was the test data or which operator ID was doing that. So if we identify, oh, the problem is because of this lot, from this supplier causing the problem. And then from the system, we can very easily do a forward trace. What are the serial number is using the same lot of the material. So this is traceability for backwards and also for the forward tracking. So lastly, before I end the session, I will do a summary. So MES actually bridge between operational cooperation management and process control level, like what I shown in the topologies. So it provides transparency in the shop floor management, and also they give you a real-time insight into the machine and the system. And also, MES help the companies to meeting the regulation, especially for pharmaceuticals, EMS, for the tracking of the products. Okay, that's all for my session. You're welcome to raise your question. I think during the Q&A session, we will answer your question as much as possible.
Yeah, great. Thank you, Mr. Alex. All right, now moving on to the second half of our session today with Dr. Chua Wen Chet from the Malaysian Smart Factory 4.0, which is an initiative by Selangor Human Resource Development Center to deliver hands-on and competency-based training programs to support workforce and talent development in the fields of IoT and smart factory. So the MSF team is led by Dr. Chua, who is our second speaker for today, and obtained his PhD in Control Systems Engineering and Bachelor of Engineering in Mechatronics Engineering from Monash University, Malaysia. His key area of expertise lies mainly in the area of control and automation systems, fault detection and identification, and predictive maintenance strategies, which are widely used in the Industry 4.0 applications. Dr. Chua, the floor is yours.
Sure. Hi, good morning, everybody. Let me just quickly share my screen. Okay. All right. Can everybody see my screen at the moment?
Yep, all good.
All right. So good morning, everybody. My name is Dr. Chua, and I'm from the Malaysian Smart Factory 4.0 at Selangor Human Resource Development Center. So this morning, what I will share with everybody would be more deep dive into the benefits of overall equipment effectiveness for smart manufacturing. All right, which I will discuss more on the OEE in general, how you implement it, what kind of strategies that are there to really support the industries in terms of implementing OEE. Data formulation, which is something that is very important. How do you calculate OEE automatically throughout an entire manufacturing system? And how do you improve your overall equipment effectiveness in your current factory operation through talent development strategies? So this slide here shows you a very brief picture about OEE. Right now, we always think that overall equipment effectiveness is a very complicated kind of analytics, but actually it's not, right? It's basically broken down into three major components, which is availability, performance, and quality. Now, these three components will actually provide to you a real example of what is your overall equipment effectiveness throughout your factory operations. So let's look at the equation of effectiveness, the OEE. Now, OEE is a journey which requires a clear, distinct understanding between effectiveness and efficiency. Now, effectiveness is basically the relation between what is your theoretical or ideal production output versus your actual production output. And efficiency is generally a relationship between the effectiveness of your machine running and the amount of effort that you put, right, that you require to achieve that level of effectiveness, right? So the power of OEE is basically broken down into three major components, which is your availability, performance and quality, which tracks down the area, all right, where your losses occur throughout your manufacturing process. So now what constitutes availability, performance, and quality? Now, if you look at this chart over here, availability is basically producing products as planned, right? You have 8 hours in a shift, okay? How much within that 8 hours your machine is actually available and producing products, right? Basically reducing your downtime and minimizing your time losses. So some of the key parameters that you will track basically is like downtime tracking. That's very, very important in terms of your OE. You need to know when your machine is actually idle, when your machine is actually down, and that is basically your overall availability. Now, talking about performance, right? It's about producing the right product at the right speed. Now, if you buy a machine and it's supposed to produce 10,000 products in an hour, right? Are you actually producing 10,000 products in an hour? That's basically your cycle time, right? Your machine process time. So are you actually achieving that level of ideal production speed? So that's the area that you need to find out. And some of the key parameters that you will track, are like product traceability, right? Product in, product out. What's the time range? Your machine time, your machine idle time, if your machine is reset. And of course, your elemental cycle time study. That's very, very important to determine your actual production speed versus what is in your specification for this machine. Now, then when you talk about quality, in overall, what we want to achieve is no defect, no rework, and no wastages, right? So some of the key parameters that you would track is material, raw material coming in, finished versus your finished product. What are the criteria spec? Is it pass, fail, or incomplete? Sometimes when you look at the entire analytics, right, of raw materials coming in and product coming out, you may or may not see a trend of a production quality related to your raw materials that are actually coming in, right? So sometimes it's a material trend, or it could be a process trend. So these are the things that you can identify through implementing OEE in your particular manufacturing system. So a simple illustration, right, of OEE, right? You have a planned production time, which is, for example, you plan to produce 1,000 pieces in an hour, and your available time is 8 hours. So your ideal output for a day, okay, if nothing happens, is 8,000 pieces, right? So let's look at availability. Out of the 8 hours, you only get to produce, you only get 6 productive hours after you do machine changeover, after your machine is down, your operators have to go on break. Sometimes you have minor stoppages because you need to change some processes in the machine, your startup time. So overall in a day, you only have 75% of your total available time. Then talk about performance, right? Your machine is supposed to produce 1,000 pieces in an hour. But when you look at the average production in a day, you only get average of 700 pieces an hour. So basically, you're only performing at 70% of the capacity that your machine is supposed to run. Then you talk about quality. After, producing all the parts, basically in the 8-hour shift, you get 4,032 pieces produced, but 168 of them are actually defective. So if you look at availability, performance, and quality, in terms of percentage, right? When you look at that, they are above 70%, right? But if you combine them together as a metrics to calculate your OEE, right, which is a combination of APQ, you only get 50% of overall equipment effectiveness, right? So that's actually your key highlight to understand where your production losses are in terms of your A, P, and Q. So what are some of the losses that you will see? When you identify from APQ, what are the ideas of losses that you will observe from that kind of data logging, right? You talk about breakdowns, right? You have machine breakdowns, you have setup adjustment time, which takes up your total available time. You have idling and minor stoppages, which will cause your cycle time to increase, right? And then you talk about your speed of your machine. Sometimes it's not operating at the optimum speed. Sometimes your machine is supposed to operate at a very high speed, but if you operate at high speed, your production defects are very, very high. So sometimes you need to consider that kind of scenario as well. Effective operating time, like, you have defects in your process, you have defects in your rework, startup losses when you do changeover, when you want to do some test runs, those are losses that you need to account as well. So what are these things called? These are called the 6-week losses in OEE manufacturing. So a very general outlook on this, like a summary of it. If you want to talk about availability loss, then you talk about unplanned stops, which is your equipment failure, downtime. Planned stops will be setup and adjustment. So sometimes during a changeover, you need to have some setup time. That is your planned stops, right? Performance loss, right? If your machine is having slow stops, which is something that is not easy to see, especially when the conveyor starts moving. How do you know that at a certain interval it actually start to jerk or stop? We will never know unless we track it, right? Slow cycles, reducing your speed. Over time, equipment gets wear and tear. Is something that we need to track, and it's something that we need to identify. So those are items that you could track using your performance measure, right? Then we talk about quality, right? Production rejects, process defects, startup rejects, which reduces your overall yield in a day. And overall, you get your OEE, which gives you your full productive time and talks about your full effectiveness of your system. So now, talking about that whole general about OEE, how it actually works, and what APQ actually stands for. Now, what are the form of strategies that you need to implement, towards achieving your OEE calculation, right? So we sort of break down the components of data automation into 5 levels of maturity, right? So OEE actually falls under, in our perspective, at level 4, right? When you talk about data formulation. So because when you talk about data automation, first thing you need to do is you need to collect data. So that's all in level 1. Then you need to visualize your data, right? You need to know how your data trends are moving. And then you need to store your data, because when you want to calculate your availability, performance, and quality metrics, you need to store it, see a historical trend, then do your formulation, which is in level 4, right? So that's basically how we measure the maturity levels for industries in terms of where they are to implement OEE automatically in real time. So let's give an example. This simple machine over here has 3 sensors, right? Which is your input and output sensors. And then you have an inductive sensor, which tracks whether the part has metal or non-metal. That could be your quality metrics or your quality KPI. Emergency stop button, start button. Basically, that's a very common buttons in a system, right? So if you talk about APQ, this is basically some of the form of calculation that you can have. It could vary from different industries depending on how would you calculate your AP and Q. So not all industries, have the same kind of measure, but the main component of it is actually identifying what is a key parameter that you want to measure, right? How do you measure performance in your particular industry operation? How do you measure availability in your particular industry operation? And how do you measure quality in terms of your own industry applications? So in this aspect of this machine example, right? How do we track availability? Where can we get that information of availability in a particular machine? Simple thing is tower lights, right? If your machine has tower lights, which most machines do, red lights will usually mean your machine has problem, your machine is down. Green light will tell you your machine is good to go. Yellow, maybe your machine is idling, it's waiting for changeover, maybe, right? So that information already tells you your machine condition. Emergency stop, start, and go tells you whether your machine is running or not running. So that already tells you an information of availability. Performance, right? The easiest way to track. Machine go in, part go in, part go out, right? So input and output sensors, tracking your part in and part out will give you your performance measure. And the last one will be quality. So what quality metrics are you using? Is it visual inspection? Is it push buttons? Is it quality sensors? So those sensors available will give you the exact metrics that you need to calculate your OEE for your machine. So this is just a simple example of how we calculate our OEE in terms of this dashboard, right? So this dashboard is developed by our team. This is actually what we can teach you how to do. So in this scenario, exactly what I showed you earlier, we calculate availability based on calculating downtime, right? Planned or unplanned stops. So if the machine is down, it will calculate its overall downtime. And then based on the overall downtime versus your actual production time, that is your availability. Performance, calculating the time difference between 2 sensors, that is the simplest way of calculating your machine part in and part out, right? So based on the time, you know that, okay, to complete one process, I take 4 seconds. To complete this process, I take 10 seconds. So you already have that metrics, right? So then you already calculate your overall performance in a day. Quality actually is based on just calculating defects, calculating losses. So if there's a reject count, press the button. If there's another reject based on quality, press another button. It's that straightforward. So all this information that you get, you can, once you generate the data from level 1, you can straight away put it in a dashboard, formulate your OEE calculation, and just basically develop a simple dashboard like this. It already can show you what is happening in your machine at a particular given point of time, right? So what does real-time OEE do for you, right? It's all about minimizing time losses, right? You want to know when your machine has an issue. You want to know when your performance of your machine is dropping, when your OEE is actually dropping over time. So it's all about minimizing every single time delay to make the right decisions, right? So over time, machine wear and tear, over time, you can visualize if your machine is down or is running at a correct pace. Then you know that you can take the right interventions to ensure that you actually put in the right measures, right, the right actions, and make the right decisions at a very given point of time. So one example that that I met with an industry where we support them in terms of building their own OEE system, right? So what they shared with me is before they implemented OEE for their own system in terms of automating every data collection. That means there's a lot of transparency in data. There's a lot of integrity in the data collected. So what happens is that they found out that, okay, actually production is supposed to start at 8 o'clock, but operators only start producing parts at 8:15. So you see 15 minutes is already gone doing nothing in an actual available time. So what does that constitute? That means that your availability, your total available production hours in a day actually reduced by 15 minutes, right? So what if they take longer breaks? What if they go for longer toilet breaks, and all that? So all these need to be accounted, and you need to see that metrics running in a whole day in real time. Then you know what's actually happening, and you can take the right intervention strategies to help to improve your OEE. So in overall, what is trying to discuss here in terms of OEE is time is money, right? And therefore, it is also everyone's responsibility. So if you look at a typical OEE metrics, right, in terms of a global world-class standard, right, 85% of OEE is considered world-class, right? A typical OEE for a factory is 60%. But what you, of course, want to achieve is higher than typical. You want to achieve world-class, and therefore, automating your data collection is very, very important in terms of your OEE calculations. Definitely 40% and below is not encouraged, and therefore we would hope to support industries to achieve what we call as world-class OEE, because by doing that, by achieving world-class OEE, a simple automation of data intervention strategies and all that will help you to reduce your cost of downtime, reduce your cost of performance losses, and therefore reduce your cost of quality issues. Therefore, all your total losses and wastage will reduce, and you can definitely save a lot of costs from there. So it is a role and responsibility of every personnel in the factory floor, to really support the OEE initiative, right? Or OEE projects that you want to do. So you need to provide clear definition of how data is collected, because you don't want data to be collected and then it becomes redundant. It doesn't give you any information, right? And you need to know what kind of key parameters are you tracking for each of your machine. Every machine may have different operations. Every machine may have different cycle times. So that's something we need to identify. And once you identify, you need to validate your cycle time, right? For performance measurement, review your losses at the start of every shift, downtime and performance quality monitoring in real time. That really provides you greater insights and greater control towards how you want to improve your OEE process. And suggest data-driven improvements, right? When you make decisions, it is based on data, right? You know that, okay, operator is taking longer breaks. This is basically the data to prove it. That's how we want to, that's where we want to tackle the losses, right? Performance issues due to machine needing more maintenance, right? Or scheduled maintenance. That's where you need to deep dive in. quality issue is due to raw materials coming in or operator dependent. So that's where you can suggest data-driven improvements based on observation and production line to set and track your improvement targets. So that really helps in terms of moving your OE to world-class and of course to much better operations for your factory. So the key advantages of implementing OE in your production system, it really gives you greater production insights because it drives data-driven kind of strategies, increased competitiveness. Basically, if your entire floor has these metrics already calculated and reviewed in real time, it gives customer confidence, right, that you are producing parts more efficiently, more effectively, and you are ensuring that your cost, you reduce your wastage and therefore your cost is actually kept low or more competitive. Real-time productivity insight. Now that gives you a real measure on what your machine is actually running, whether is it effective. Reduce machinery costs. Basically, once you know that your machine is having some issues, due to performance, you can actually put in some right measures to actually do maintenance strategies to ensure that your machine is kept operating at an optimal level. You improve your machine utilization. Basically, you can see which machine are idle, which machine are not well utilized. You improve your production output, you visualize your performance, you achieve more efficient operations, and of course, optimize your workforce for improvement. So, if you automate your machines, and in your factory floor, I'm pretty sure you have at least 45 machines probably. If every machine is automated to calculate its own OEE, you don't need to do manual tracking. You don't need to deploy more staff to actually go and calculate your OEE at every hour, for example. The whole automation strategy does it for you. So you get to optimize your workforce for future improvement. So in general, what I've shared is all the strategies that you can do to implement your OEE, how beneficial is OEE for you. And of course, now the idea is how do you improve your OEE through talent development, which is essentially what we do at SHRDC. So in terms of our Industry 4.0 programs, OEE is also one of our key components. It is part of one of our recipe programs, which is part of our level 4. So if once you're ready to start your journey in terms of your OEE, we would definitely recommend this program for you. For those companies who have not automated their data collection, we do have other programs as well for you, which is level 1, data generation, which you can start that journey with us at any time. So in data formulation, what we cover is we really help you to identify your key parameters required to monitor your OEE, to calculate them, describe the approaches to calculate your APQ. That's very, very important. Really help you to identify your 6-bit losses. Where is your losses are. Construct a process flow to monitor APQ, which is basically helping you to develop your software for it, a simple software to calculate. Construct your process flow to formulate a calculation in real time. And of course, we also have hands-on session to integrate your software to the hardware that we have to verify your OE system that you develop. So in general, our programs are following this kind of framework where you don't need to worry in terms of what machines you have and so on. Basically, the calculation of OEE is brand independent, and we can support you based on this framework that we support most of our programs as well, which we go with multi-vendor, open communication, and help you to develop rapid prototyping. This is some of the key areas that we support in terms of Malaysian Smart Factory. We do a lot of tech talent development. That's what we do as a core. After CMCO, we definitely welcome you to visit the Smart Factory. We have the space as a technology learning platform. Proof of concepts and lighthouse projects are what we do. And of course, live demonstration of technologies are also there together with our partners. And digital training platform is something that we are focusing on as we go along in this pandemic. So the journey of SHRDC, if you want to find out more about what we do, we have a lot of webinar communication series on our website, past, present, and future, right? So do check in with us. Our program details are also on the website. From time to time, we also will share some of the new initiatives that we have. So keep yourself updated in our database as we continue to inform you of more different initiatives that are there for Industry 4.0 and how we support the industries. So with that, that's all I have for everyone today.
All right, great. Thanks, Dr. Chua. Yeah. So now I would like to pass the session over to my colleague Eileen for the Q&A session with Dr. Chua and Mr. Alex.
Thank you, Isa. Good morning, ladies and gentlemen. Thank you for joining us for the session today. I'll head straight into the Q&A session. Some of you have posted questions earlier on, so we're gonna, and they have been answered directly, but I'm gonna review those questions and answer and get either Alex or Dr. Chua to answer so that everybody would be in the know and be part of the discussion. All right, first question from Mr. Yao. WIP is not in the BOM bracket ERP. Can MES manage the WIP stocks? Alex, would you like to answer that?
Okay, yeah. In fact, if you design your bill of material in your ERP to keep track of the WIP, it is feasible. I mean, but you have to create a lot of levels because every WIP you need to create them as a made-in part. Okay, so every made-in part when you run MRP, it will suggest you to create a work order. So that means every WIP is a work order by itself. So if you want to use that to do for your ERP, right, then you will have a lot of job order in your production module. So if let's say you have a simple process, then it's okay. But if let's say your process involves multiple process, that every process you want to keep track of the WIP in your ERP, that will be very, very tedious. So this is where you use MES to complement ERP to do all this WIP tracking. So in ERP, you can still use your create your BOM as per usual, but you use MES to define those processes of the WIP. So when you complete this process, the quantity move to the other process, then the MES will track the WIP. So you don't need to track all this thing in ERP because it's just too tedious. Then until the finished good is produced, right, then only we will receive this finished good into the ERP. Then you track the WIP in MES, then ERP monitor your work orders and also what is the quantity completed in the shop floor. That will be nice.
Okay, I think he has a follow-up question. It's also in the Q&A box. He's asking, does he probably need to have another set of inventory data in the MES, or it will flow through? I guess that's his question.
You see, MES track the inventory in the shop floor. This is what ERP don't do. I give you one good example. Okay, so you have a work order. Okay, you want to produce 1,000 units. Okay, and the quantity per in this BOM is 1. So meaning that you will issue 1,000 pieces of the raw material to the shop floor. Okay, so ERP will minus off this 1,000. Okay, but in fact, this stock is in your shop floor. Okay, but how to monitor this 1,000 now is how many left in your shop floor. Okay, that is what MES does. So MES will actually transfer from ERP and then we'll go to the WIP location into the MES system. So for example, after you complete 10 units, I will minus off 10. Meaning that I will show you, oh, your WIP for this stock, you still have 990. Okay, so this is what MES is doing. So it track the WIP. Or if let's say you don't have a MES system in the shop floor, meaning that this is 1,000 after you issue, you really don't know what is the balance now in your shop floor.
Right, thank you, Alex.
Yep.
The next question I think is also related from Mr. Koo. He's asking, is it common in the market for both MES, ERP to be of different software, different programs? And if yes, how do both software or programs communicate with each other?
Yeah, very good question. Okay, actually very common. Okay, out of the customer that we have done so far, so their ERP and MES is different. Okay, so no doubt there are some ERP software claiming that they also doing for the MES. I mean, they are okay, but it's totally two different kind of the expertise. Okay, So the answer is actually yes and no. So I mean, if you search from market, there are some ERP also doing MES, but it's very common that the MES and ERP is different, and it really depends on the industry that you are into. So this answer is yes and no.
Okay, thank you for that, Alex. We've got another question, anonymous attendee. He is of the idea that software communicate through SQL data interchange. He's asking for clarification.
Yeah. So when you talk about the communication between ERP and also MES, usually before we start any project, then we will sit down with the ERP vendor. Okay, we depends on what software they are using, and then what are the communication method that supported by both systems. But of course, a lot of time, ERP the protocol is quite fixed. MES usually we have to suit to the ERP protocol. So there are many ways. I think one of the attendee they ask is via SQL. Yes, it can be done. You can do some bridging tables to communicate between two systems. So the other most I think those are branded one like SAP, Oracle's. Usually they have API library. So and then we will communicate with them through the API library or web services.
Okay, one more final question for Alex, not final, but before we move on to the new questions coming in. This is from the chat column. He's asking, Mr. Singh, in the shop floor, normally there are many types of brands and of controllers for individual machines. They talk in different protocols. How do we do the integration or get data from them?
Wow, that's why I say this is also, I think it's a very, very realistic problem in today's in manufacturing. Yes. So it's not that they don't want to move into industrial 4. It's actually, wow, there are some machine is running on counter. They don't even have PLC.
Yes.
Okay. There are some using Mitsubishi, some using Delta, so many different brands. So how to communicate. Okay, usually what we suggest to them, we will go there and do a site study. Okay, so we will advise our customer not to be so ambitious. If you want to do all this machine connectivity, you do one shot for all. So you just pick those, a critical one. We select based on their priorities, and then we select 1-2 models, and then we do a POC, and then to do the connectivities. Of course, if let's say you want to do it for the long term, then we will encourage you to take some trainings, so to study some of the IoT protocol, to take some PLC, this kind of the courses. Then you can have your internal talents to do the kind of the data acquisitions. That will be a long term, because today, if you want to convert a traditional factory into connected factories, it's a very long journey.
Yes.
Okay, so I see some of the customer, even those they have automation team in their company, when they plan for their automation journey, right? They talk about 3 years plan, 5 years plan. It's a lot of work to do, a lot of talent and skill that is required.
All right, thank you, Alex. Dr. Chua, do you want to sort of explain a little bit more on how we can help in terms of that data acquisition bit?
Yep, sure. So basically, in terms of data acquisition, for our programs, if you want to look at training programs to upskill your own team internally, we do have programs that support data acquisition from the factory floor. And our methodologies of doing that basically are brand independent. So we have many strategies of collecting data. One is a non-PLC based method, which we basically will look into signal tapping. Second method is actually looking at PLC to IoT gateway integration. So that also can collect data from your machines through an IoT gateway. However, the key important part is, do you have access to your PLC? That's very, very important because you need to release some communication protocols which are open, and then you can definitely tap from there. So those are your data acquisition strategies. But of course, for us, we can, of course, scope out what you have in your factory floor. Like what Mr. Alex has shared, some of the factory don't even have PLC. So we need to see how you want to collect data from your process, right? Which is mainly from sensors and actuators, that you can then collect some information from there.
All right, thank you. Singh, I hope that answers your question. We now move back to the Q&A box. We've got a question from Alvin. What is total effective equipment performance? He's asking if we can explain it in a bit of more details.
Yeah, maybe I'll explain this one. So just now, when we talk about OEE, when we talk about the 3 parameters APQ, TEEP, or total effective equipment performance, actually looks into one more factor, which is your 4th factor in this multiplier effect, which is your utilization, right? So TEP looks at APQ and U, actually. So U actually looks at utilization, which actually looks into your overall scheduled losses. For example, if your plant is not operating, your plant is shut down, that is your scheduled losses. Your production is not scheduled, meaning to say that you have no production running, that is your scheduled losses. So your TEP looks into your overall plant operations and talks about your scheduled losses in the whole run, which is like plant shutdown, no orders, breaks, lunches, all these need to be included under your utilization.
All right, thank you. Next, we have a question from Noor Aisha, and it's for you, Dr. Chua. You mentioned that OE calculation is independent to the type of machine, so how the sensors are connected. And she has a top-up question, especially related to the machine.
Okay, so machines would really depend on what your machine is operating. So like what I shared earlier, to calculate your AP and Q, you need to identify what are the parameters that constitute calculating your downtime. That's number 1. So downtime is 1 sensor. Number 2 is your input sensor, that means part going in, output sensor, part going out, and what is your quality sensor or quality metrics that you're trying to measure. So in general, I would say that these 4 parameters are some areas that you need to identify, at least to calculate your AP and Q. So when we talk about independent to the type of machines, what we mean is the method of collecting data is independent of the machine, right? Most machines with PLC communications would have some form of open protocols, which is either through Modbus TCP, Modbus RTU. That is one communication protocol that is quite common. If you don't have access to your PLC, which is definitely a challenge for some of the industries that we have visited, what we recommend is a non-PLC based method, which is using a gateway to actually tap the signals into an I/O port, and straight away you can generate data from there. So those are some of the strategies that we have supported some of the industries that have gone through our data generation program. That's the level 1. So you will learn how to tap signals from a machine to get data, and then you can identify what is the metrics to calculate OEE in the level 4 program that we have. Yeah, so that is a continuation part. Yeah, so therefore, that's why I mentioned that it's independent of the machine.
All right, next question again for Dr. Chua from Singh. Can you advise how OEE can be defined for a complicated production line? For example, if the line consists of many island types of machine and to link it all together. Island, I guess in this sense, is meaning all not combined, not joined, separate and independent. So
I think from this perspective, you can do it as a separate OEE calculation per machine. That's actually possible. Like you can look at station 1, station 2, station 3, how the machine is actually operating effectively throughout the whole production cycle. And then you may want to also consider travel time, right, between one machine to the next machine, right? What is the time taken from product A, process 1 to move to product A, process 2, right? If your machines are in an island. So from there, then you will look at your summative OEE in your whole production line, right? You look at the sum. There are many ways of calculating it. You can look at the sum, the average sum of every machine operating, what is the total cycle time in general, and then you can put it together. So that is one way that we can do it. But of course, there are many, many ways. We need to identify first what you want to calculate. Is it you want to calculate your total production OEE, or you want to calculate your independent machine OEE? Then we will see how to strategize that and how would you calculate effectiveness. So the first step, that's why I talk about level 1 to level 4. The first step is to look at your data generation first, get data to your machines out, individually, look at the trends, look at your data storage, collect them, then use that data in your database and start formulating what works well for you in terms of measuring your OEE. Then you can see how to seamlessly integrate everything together.
Okay, Dr. Chua, I think Singh has a follow-up question. So he's testing it. Have you, does it make sense to calculate it this way, to formulate it this way?
Yes, that, like I said, there is it is possible for this method as well, depending on what you want to track. So because we have to remember that every machine has its operating efficiency, operating effectiveness, but we also need to account for travel time between machines for parts, right? So that also accumulates to time because your time to travel is there. So that can be considered like your overall cycle time, your cycle time from machine 1 to machine 2, that is your cycle time, right? To travel there. So it's like a conveyor time, right? So that will actually give you more insight and analytics to your overall OEE. So I would say that the equation that you provide needs to have probably integrated the time travel between machines as well.
All right, thank you for that. I think we go back to Alex.
Yeah.
This is a question from Chung, and he's asking, how seamless is your MES in terms of connecting to existing ERP, or do you have a favorite ERP system protocol?
Yeah, so usually we how to say, we really depends on the ERP vendor. Okay, so because they are the core, okay, and a lot of factory, right, they already have their ERP system in place. So very few options that we can select. So usually we will work with them to see what are the best protocol to do. But usually, I mean, we use API library. So this is more proper, okay, compared to on the SQL level. So because API that, you have all the business logics are in place. So whatever data exchange is more proper. And then especially when you deal with those tier 1 kind of the ERP, then I think this is on the way.
Okay, thank you for that. All right, I think either one of you or both of you can choose to answer the next question from Ken Chow. How is business intelligence BI different from data analytics?
Maybe I'll answer this. Okay. BI and data analytics is two different things, but but the source is data. I mean, both of them need data to do data analytics and BI. So, but if you look at data analytics, right, is the scope is actually deeper. It's deeper. So BI is actually a tools for you to dissect the data and then present it into graphical form. Okay, so but data analytics you do more. So you can do simulation. So last time when we talk about data analytics for some corporation, right? So I can models my corporate, I think my subsidiaries, all the child accounts. So then I can do a simulation to say, oh, what if I increase 5% of my sales? Hey, what is the impact for my this net profit? Or if I say, oh, now I remove these subsidiaries, what is the impact for my P&L? The kind is data analytics. So you need to have the models, and then you can do a lot of simulation. But BI is based on what the data cube that you have. I just present it into the graph, all these things. So it's two different things.
All right. For the benefit of everyone on board today, we will be hosting in 2 weeks' time another webinar, and we'll talk more deeply about data analytics. So keep an eye for the invitation. Thank you, Alex. Next question, I think is OEE related from Izam. He's saying not all quality issues will be raised on a real-time basis. And for this particular issue, quality, how will OEE sort of solve the problem or improve the situation?
Yep. So basically, in terms of quality issues, we need to identify the process on how the quality issues are raised, right? Is it, would you collect like a batch of products and then move it to another station, like a whole batch, and then you start doing like vision inspection, manual vision inspection of quality? or do you do it on the go? So this is something that the industries will need to identify what works best for them. Then, like I said, OEE, even if we monitor it in real time, right? There are also methodologies from some companies that, they don't need it to be monitored every hour. They want to monitor in maybe like every different cycles or different sampling rates. So it really depends on the industry, how they want to quantify it. So let's say if, for example, you only want to measure quality maybe every half a shift, right? So every half a shift, you just update into your OEE calculation that out of all your, your production running, your quality matrix will only come in at the end of a shift or at the end of half a shift. That's also okay. But at the same time, you can already start to monitor your A and P in real time, right? You can monitor your downtime in real time. You can monitor your machine performance in real time. That is okay. And quality issue, maybe it will come in later on, which you also can include it. So it really depends. If you want like real-time OEE, including quality, right, to give more insights to you, then you need to put in some other quality measurement factors inside your operating system. So for example, at the end of the station, when you collect your parts, right, the operator is already looking at the parts, they'll put it in a basket. Maybe basket 1 is actually quality issue. Basket 2 is maybe good products. Then from there, you can really start to calculate your quality issue. Yeah.
All right. I think Izam has a top-up question. It's about how do you calculate the overall OEE? For example, 30 units of machine.
For example, how to calculate overall? Example, you have 30 units of machine. Well, basically, you can do the same example of calculating every machine's OEE, and then multiply it or sum it, and then you get your overall equipment effectiveness of all 30 machines. So it really depends on how you want to calculate your overall effectiveness for your factory. What information works best for you, right? For example, if you take machine 1 to machine 10, maybe it would actually be a better effect of efficiency if you actually multiply that data instead of summation, right? Because summation, then you have to take the average, but maybe average may not give you the real multiplier effect. So you may want to multiply it, then you can see, okay, in my whole line of station 1 to station 10, actually I only achieve actually 50% of OEE. So then you drill down to every machine, which one actually contributes to that 50%, right? So that multiplier effect will give you more information.
All right, thank you. Singh has another question for you, Dr. Chua. Any relationship between OEE and machine utilization?
Okay. So OEE, basically you are also calculating availability, which also means your machine uptime. And when you look at performance, another quantity that you can also add in, okay, which is basically your machine mileage, right? So mileage would mean that every product that goes in, how many cycles have you actually produced a product? How many cycles have you actually run? Whether or not it's a fail or pass product is actually your mileage of your machine. So when you talk about mileage, then you know your machine utilization is up to how many level. It's exactly the same like how you measure utilization of your car, right? The more you drive, the higher mileage you have, right? So that gives you a perspective on your machine utilization. And if your machine is idle, is kept idle, you already know that, okay, from let's say 8 a.m. to 10 p.m., this machine is not scheduled for any production, therefore it's left idle. So therefore it's not running, your mileage is low. So then you get the overall perspective of your machine utilization as well. And you can sort of put that as an analytical data later on to predict maybe your next maintenance schedule. You can talk about your remaining useful life of your machine. So those are information that you can use to do relevant predictions later on.
Okay, thank you for that. Right, another question, anonymous attendee, and he's got a statement, he's got a question for cybersecurity. So he's saying that when we move to smart factory, he thinks cybersecurity is one of the key elements to be addressed. And he's asking the opinion of both panelists on adopting the Purdue model for industrial control system. Is this a must for the future? And what is the view of cybersecurity for OT? So who wants to go first?
Dr. Chua?
Okay.
Sure, no problem. Okay, from my very general or basic understanding on the Purdue model, what I understood it from a factory perspective, the important part is to identify vulnerabilities, right? When you implement your systems in your smart factory, vulnerability would mean that is your IP addressing or your ports actually exposed, right? Exposed would mean that do you have public access to it? And most of the time, for the factory floor, there needs to be certain cybersecurity measures put in place. Either you have firewalls, or you actually develop a demilitarized zone, DMZ zone for your factory, right? So that's an important thing to think about. And also, when you implement your software and all that, it needs to be password protected. You need to make sure that all your system integration has a good login criteria and details. And therefore, that will actually help to sort of protect your systems in place. So identify your vulnerabilities first, okay? Make sure that they have, you have proper firewalls in place. Some industries, they actually do like totally cut off the internet for the shop floor. We won't encourage that because actually when you talk about Industry 4.0, we talk about connectivity and having data being sent to the cloud and all that is something important moving forward. So instead of cutting off everything, we need to identify how to prevent threats or penetrations in the factory floor. Most important to also identify is also your backups, right? Okay, every machine should have your edge backup. It should also have your on-site database backup and the cloud backup. So in case something happens, you still have your data there, right? It's not totally restricted. So something that every industry need to consider for the future when you do your enterprise planning to move and scale up your smart factory scalability. Yeah?
All right, thank you for that. I think it's very important for people to realize that data is the new commodity, equivalent to gold these days. All right, next question. Just to recap, anonymous attendee, if there is no PLC, can it be compensated with the gateway hub? Either
yes.
one of you can?
Yeah.
All
yes,
right.
you can.
Right.
Definitely, most of the time now you would use, I mean, a lot of systems have IPC. So as long as you have an IPC with IO ports, you can consider it as a gateway to collect data. So that is no issue.
Yep.
Okay. Last two questions, both from Chung. What is your average implementation time and what is the downtime like after system study? Maybe Alex?
Oh, so because I don't know whether this is addressed to OEE or this is addressed to MES.
Yeah.
Okay.
You
so
try to answer from both.
Yeah. So like typical kind of the MES implementation, right? So we talk about 4 to 6 months, 4 to 6 month kind of the lead time. Okay. Downtime is really depends on whether this MES needs a lot this machine connectivities or not. So a lot of time when we implement for some customer, right? So is they set up a new line. So because they got new orders from customer, so and then it's during the line setup that we implement the MES system. Okay, so but if let's say you talk about OEE kind of the implementation, right? Definitely they involve some of the downtime. So then we have to work with customer to see when is the best time. So if let's say they want us to do some connectivity during the weekend or whatever, then we have to study with them. Okay, so but before that, we will do all the planning, the schedules for the downtime for machine connectivities.
Okay, Dr. Chua, you want to add to it? Because he's asking for both.
Yep. So like what Mr. Alex has mentioned as well, it really depends on the customer or the industry. Whether they are, number one, if they're setting up for a new line, I think there's more flexible in time for implementation. But if it's for existing line, basically the key component of the OEE calculation, number one is collecting data first. So how do we collect data from the machine is a method that we will need to consider. If you are doing some hardware integration, that will take maybe some time or some downtime to do wiring and all that to wire to the hardware. The rest of it, once it's wired to the hardware, is all software-based. So software-based, then it will depend on your engineers on hand, how fast they will take to do the integration. But if they do it as a software-based, because you're just collecting data, you're not controlling the machine, it shouldn't account to any downtime, right? Shouldn't, because your machine is just operating on its own. You're just collecting data, you're just formulating it offline. Therefore, there shouldn't be any downtime included. So the downtime for us in terms of OE implementation, from my perspective, will just rely on the hardware portion. Yeah.
Okay, thank you. Izam's got another question. Will OEE be captured within the MES and ERP modules? Alex?
MES, of course.
Yeah.
Yes.
Yeah, it's MES because
Okay.
if you link so many data, I mean of the machine data to the ERP, then the ERP performance will be slowed down. Okay, so usually this is because if you see the sensors, this is the topology that I mentioned. Okay, so the sensors, the machine should go to MES first. Okay, then only to the ERP.
Yes, and the more data you can collect, the better picture you will get.
Yeah. So let ERP handles all the dollar and cents, supply chain planning.
Yes.
Those dirty job, leave it to us.
Okay. All right. Singh has got a question for Alex. And you talked about using mesh Wi-Fi network to link controllers and gateways. So he's asking for recommendation. And he's saying that they need some support in that area.
Yeah. So I think, Sang, if let's say you need any help, I think we can send our consultants to do an on-site study with you. So far, I think the brand that we are using is from Taiwan, is Nexcom. They are actually industrial kind of the player. They're producing IPC, touch panel, Wi-Fi MES, and edge server. So far, I think we have installed quite a number to our customer. The response is quite good. Okay, so if let's say you want to know further details, maybe you can send to Isa, and then from the email, I will reply to you and recommend to you. So if let's say if you really need help, right, I think we can also schedule a visit. I think we'll get our consultant to pay you a visit.
I think we will share the contact details before we close the session. Thank you. Last question so far from anonymous attendee: is warehouse management system also part of ERP?
Yes, how do I put it? Some said it's in between, you know. We can't say it's part of ERP, it's also part of MES. Okay, you see, when we implement for a customer, so our customer is using our WMS. Why we say it linked to MES? Because of the product traceability. It really depends on, you know, what you use for the WMS. If you say, oh, you just want to have a system to do the put away, the picking, to have the location of the stocks, okay, so you know, FIFO, you know, where to pick all these things, and then that can be part of the ERP. But if you say, oh, I want to do product traceability, like my customer, they say, you know, I want you to link all the stock information at which location to the shop floor, meaning that when you issue any stock to this particular work order, I want you to track, you know, from which supplier, which location, are you issue based on FIFO, and then I want you to keep track the shelf life, and also in MES we call another one is called flow life. Flow life meaning that after I issue from the warehouse, you know, how long it stay in the flow. It cannot, you know, longer than certain period that I expected. That is flow life. Like just I mentioned, the solder paste, you cannot, you know, stay in the shop floor more than 24 hours. If more than 24 hours, means that my product has a risk that, you know, have high rejection, high defects. So if you need the kind of the traceability, then this WMS may have to stay under the MES. Because the common WMS, they might not be able to provide this kind of capability.
All right, I think that's a really good answer. I hope that answers your question. And that marks the end of the Q&A session, and it's really, really good. We've got, I think, shared some very good insights and recommendations. Thank you very much, ladies and gentlemen and panelists. I'll hand the session now back to Isa.
All right, thank you, Gillian. Thank you, Mr. Alex, and thank you, Dr. Chua, for today's session. I think it was a really productive session with all the questions and your